Hey GED students, there's a student on Facebook who was struggling to simplify radical expressions such as the one I have written here, 4 square root of 27 minus 5 square root of 12. Okay, so just a little preface to this video. One, this is not the style of radical problems usually that I've heard of or seen on the GED. I wouldn't expect you to necessarily get something just like this on the GED. However, that being said, it's definitely going to be in your beginning college algebra classes. So I'd say still a useful skill. So here we go. I'm going to do this by hand, and then I'll check my work in a TI 30XS, the calculator we would use on the GED. Okay, so the first thing to know is to be able to read this and see what it's asking me to do. Obviously, with this minus sign here, I've been asked to subtract these two big ugly numbers. But what scares students is they often don't know how to subtract radicals. They're like, what am I supposed to do when there's this little check mark here? Okay, so I will remind you of one of the most basic principles of addition and subtraction, and that is you can only add and subtract the same kinds of things. We've been seeing that since the beginning of math with like our word problems when we added together apples and apples or oranges and oranges. We never added together apples and people, for example. And we see it through decimals and when we're combining like terms in algebra, and we see it with fractions, and we only ever add and subtract the same kind of things. So you can see that I'm stuck here. I have 4. That's the counting number out front there. It tells me how many times I have something. 4 of what? 4 square roots of 27. And from that, they'd like me to subtract 5. Well, 5 what? 5 square roots of 12. And since these two things are not the same kinds of things, square roots of 27 and square roots of 12 are not the same kind of thing, I can't yet do the subtraction. So I am going to have to start inside the radical by doing what we call simplifying radicals. Simplifying, in this case, this particular radical. The radical just refers to the little checkmark house, guys. This particular radical is what's known as a square root. Okay, so this is a square root. So what I'm going to do is I'm going to simplify a square root. Now, the problem with the square root of 12 is it's not a perfect square. Like, there's no number that times itself equals 12. Let me show you what I mean. Like, 3 times 3 is 9. So the square root of 9 is 3. And 4 times 4 is 16, so the square root of 16 is 4, but there's no number like that with 12. In fact, if you try to type this into your calculator, you'd get some ugly decimal answer, this irrational decimal answer that goes on and on forever. And mathematicians do not want ugly decimal answers. And so what we do is we simplify this. We do as much math as we can without getting to that ugly rounded decimal stage. So what I'm going to do is, even though 12 isn't a perfect square, I'm going to look to see what 12 is made of. Does 12 have any perfect squares within him? The tool that I'm going to use to do that is what's known as a factor tree. I'm going to pull 12 apart to see what factors he's made of, what numbers you can multiply to make 12. Now, you might notice that 12 is an even number, so therefore it must have a 2 in it. So 12 has a 2 within him. Now, the question is 2 times what is 12? On the other side of my factor tree, I'd like the other number. So let me count by 2's. 2, 4, 6, 8, 10, 12. I counted 6 times, so 2 times 6 is 12. Now, 2 is what we call a prime number. I can't pull it apart any further, but 6 could pull apart further. It is still an even number, so there's another 2 within him. And again, let me count by 2's. 2, 4, 6. I counted 3 times, and so 2 times 3 is 6. And now I've pulled 12 apart to see what he's made of. He's made of 2 2's and a 3. 2 2's and a 3. The end of the branch tells us what it's made of. Well, guess what? Do you see that repeated factor, 2 2's? That means there is a perfect square within 12. 2 times 2, the perfect square of 2. And so what I'm going to do is pairs pull out. The 2 pull out of the square root and become 1. And then whatever I have left, in this case a 3, it's not a pair, so it's going to stay home alone and cry. And I used to joke that square roots, simplifying square roots, was just like me on a Friday night, or anybody on a Friday night. If you have a date, you get to go out. The 2 become 1, so the 2 2's came out of the house and became 1 2. And if you don't have a date like me back in the day before I got married, you had to stay home in the house and cry. So you can see the 3 is still in the house because I only found 1 3 there. And so what I just found out is that the square root of 12 is equivalent to 2 times the square root of 3. So I'm going to replace this in my expression with 2 times the square root of 3. Now you can see I already had a 5 up here, so what am I going to do with the 5? Well, the 5 is going to be a multiplier. It is going to be multiplying with the number 2. And I can tell it's a multiplier because that 5 was shoved up against the square root. Okay, so now 5 times 2 is 10, so I get 10 times the square root of 3. Now, let's do the same thing with 27. Again, I can simplify this radical. So I'm going to simplify the radical by pulling it apart to see what it's made of. I might not know, I know 27 is not a perfect square. You know, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. So I'm not going to be able to completely square root it, but I can at least simplify it. So 27 is the same as 3 times 9. And this is why you can see I was telling you, and your teacher was probably telling you too, that these problems will be easier if you know your times tables. Because if you don't, you're going to be guessing and checking every time. And 9 is the same as 3 times 3. And so you can see that 27 is made of 3 3s multiplying. Okay? So now to pull this apart, remember, if you have 2 of a kind, they come out, the 2 become 1, so there's a 3. And then if you have one, this 3 doesn't have a pair, so he's left by himself alone in the house to cry, which means the square root of 27 is the same as 3 times the square root of 3. So I'll replace the square root of 27 with 3 times the square root of 3. And you say, but Kate, what about that 4? That 4, again, is a multiplier out front. So 4 times 3 is 12. So this is 12 times the square root of 3. Now you might say, gee whiz, Kate, why did I do all that work? This seems like an awful lot of work. Well, why? Now you can see that now I am counting square roots of 3's. This is 12 square roots of 3's, and from that I would like to take away 10 square roots of 3's. Well, no matter how ugly the thing is, if you have 12 of that thing and you would take away 10 of that thing, you're just going to have 2 of that thing. So I'm going to have 2 square roots of 3's left. All right, now if you're saying, Kate, that was a super hard problem, you left me confused. Yeah, well, it is more challenging. And usually, if we're doing this, we've already, you and I, gone over square roots. We've already simplified them on their own before we're adding and subtracting them. This is kind of like the final step in learning how to do these kinds of problems. You know, it's the most complex example. And like I said, I wouldn't expect it on the GED. All right, if you have any questions about this or any other math concept, be sure to drop it in the comments and I'll do my best to answer it.